Hello students, welcome to Web Studies, and our today's topic is Stokes Law from the chapter Mechanical Properties of Fluid. So what is Stokes Law? It basically states that the force that retards a sphere moving through a viscous liquid is directly proportional to the velocity as well as the radius of that sphere and the velocity of the viscosity of the fluid. Fine. Uh, Stokes law basically gives us an equation that expresses the drag force resisting the fall of small particles through a fluid medium, which force is called viscous force. So this viscous force is represented as F. It is equal to 6 pi nu r v. So here r is the sphere radius, nu is the fluid viscosity, and v is sphere velocity. Fine. Now, what is the importance of Stokes law? It basically helps us to determine terminal velocity first. Secondly, to determine size of sphere. First is terminal velocity, second is size of the sphere, and third is density of liquid. Fine. It can also be used to calculate the viscosity of the fluid. Now there are some applicability conditions for Stokes law. So first is the fluid flow must not be turbulent. Second, there must be no acceleration. Third, the sphere is falling at a constant velocity. Fine. The particle should be sphere and smooth. Fine. Last applicability condition is uniform. The particle should be uniform in composition. Now, what are the applications, real life applications of Stokes law? So it is firstly used in settling of sediments in fresh water, also measurement of viscosity of fluid. So these are some applications. So now let us solve one example based on Stokes law. This question says a raindrop of sphere 0.3 mm, it falls through the air with a terminal velocity 1 meter per second. Then viscosity of air is 18 into 10 to the power minus 5 poise. We have to find the viscous force on the raindrop. So firstly, the radius we have is 0.3 mm. Fine. So if we convert this to centimeter, we will get 0.03 centimeter. Fine. We have terminal velocity v as 1 meter per second. 1 meter is equal to 100 centimeters, so 100 centimeter per second. Fine. Now we have viscosity of air, that is nu, as 18 into 10 to the power minus 5 poise. We have to find the viscous force, and as we already know the formula as F is equal to 6 pi nu r v. Let us substitute all the values in it. We have 6 into the value of pi is 3.14. Fine. Nu we have 18 into 10 to the power minus 5. The value of r we have is 0.03 into the value of v. We have 100. Fine. If we solve and calculate all these, we are going to get 1.018 into 10 to the power minus 2, and the unit here will be dy dyne.